I've removed the circuit board from the chassis, though it's still tethered by some of the power supply wiring because I haven't unmounted the mains transformer. You're looking at the underside of the board in the area where the two failed resistors are, R803 and R804. Also, these two sets of three joints here and here are where the voltage regulator transistors are located. And indeed, it appears that in both cases, the solder joints have cracked. I don't think I can do much other than to remake them and hope the problem doesn't return for a good long time. I've replaced the two failed resistors and remounted the two transistors. I pushed the transistors' leads a little further through the board and bent the ends over before resoldering them. Hopefully this will make for a stronger joint. That done, I've mostly reassembled the unit. A quick test revealed the correct voltages on the op-amp power supply rails, and with a test signal applied to one of the inputs, the output seemed to behave as it should. I want to turn my attention for a moment to the front panel indicator lamps and the fact that some of them are not working properly. The main on-off switch over here is supposed to be illuminated by this incandescent lamp that's normally fitted in a slot above the switch. There are also some indicator lamps over here, not all of which are working. I'll switch the power on to demonstrate. You can see this lamp hasn't come on. The tape selector indicator light works. This one doesn't. This one does, although somewhat intermittently. And this one works. All the indicator lamps are driven by a 7.8 volt regulated supply that's generated by this Zener diode and this transistor. The 14 volts that drives this circuit and is connected to point C is derived down here by rectifying the outputs of a pair of dedicated transformer taps. The way this regulator circuit has been laid out in this diagram is a bit confusing, so I've redrawn it here to make it clearer. The indicator lamps and selection switches are mounted on this circuit board. The lamps are incandescent filament bulbs inside these coloured sleeves. The power switch indicator lamp is also connected to this board. I'm wondering whether it might be possible to replace these lamps with LEDs. Given we have a regulated power supply, the simplest option would probably be to give each LED its own independent current limiting resistor. But first of all, I want to make sure that the voltages are being correctly switched to the lamps, so that I know that, for example, the lamps that are not working have failed and it's not the switch that's faulty. And I'll also need to know the polarity of the connections to the lamps if I'm going to connect LEDs in their place. I switched the power on. There shouldn't be any dangerous voltages on this board, but I'm going to handle it with care. So first I'll check the connection to the power switch indicator lamp. Now the tape selector indicator. That's interesting, that lamp wasn't working before, although it is lighting rather dimly. So the switch contacts that supply the voltage to the lamp seem to be working, even though the lamp doesn't always come on. Seems there's a loose connection somewhere in there. Over here I fitted a high brightness yellow LED inside the rubbery mount and placed it in position above the on-off switch. It's connected to a bench power supply set to deliver a constant current of 20 mA, and I'll switch that on now. I think that works very well. I've also tried this with a white LED and I liked the appearance that produced, but I think using the yellow LED produces a result that's much closer to the original incandescent lamp. I've got another LED here, so I'll connect that instead and see how well it works when used to replace these indicator lamps. So to get an idea, I'll just hold it in place. This is how this board looks now. I calculated that a 270 ohm resistor in series with each LED would result in a current of approximately 20 mA, so that's what I've used. I fitted the resistors here, in place of some of the wire links that previously carried the connections to this front lamp board. I probably could have fitted 3mm LEDs directly on the surface of this board in place of the original lamps, but I wanted to use 5mm LEDs because they spread their light over a slightly wider angle. Unfortunately, they're a bit too deep, so I used a miniature handheld drill with a milling bit to slightly extend these cutouts. The LED for the front panel on-off switch is now inside here, and its current limiting resistor is inside this black heat shrink tubing down here. The amplifier has been on for about half an hour, and I've connected this meter to check the DC offset at one of the outputs. It's been stable at 3 to 4 millivolts ever since I turned the power on. I'll now check the other channel. The offset there is slightly higher, but that's entirely acceptable. That's a good thing because in this amplifier there is no control to adjust the offset at the output. There's instead an op-amp based servo circuit to zero the output. This is a massive improvement over the HA-4700. I find it quite difficult to adjust that for the specified offset of not more than plus or minus 20 millivolts, and I find it to be very unstable with temperature. Certainly I've measured offsets of 150 millivolts or so while the amplifier is warming up. That's not disastrously high, but is much greater than would be ideal. Now I'm going to check and, if necessary, adjust the quiescent current through the output transistors. The notes I have for this amplifier don't say anything about that, so again I'll refer to the information for the HA-4700, and that says to adjust for a voltage of 7.7 millivolts across one of the 0.22 ohm emitter resistors, and that corresponds to a current of 35 milliamps. I've changed one of the leads connected to the meter, so I now have these two probes, which I'll attach here and here. That voltage isn't too far off, but I need to adjust it slightly using this trim pot down here. There we go, that's close enough. I'll move this probe and check for the voltage across the other emitter resistor. It should be very similar. And indeed it is. Now I'll repeat for the other channel. And adjust again. There we go. Like before, I've got a 1 kHz 1 volt peak-to-peak sine wave test signal connected to both channels of the aux input. But this time the oscilloscope is set up to show both of the amplifier's outputs. This amplifier has terminals on the rear for two sets of loudspeakers labelled A and B. I've got 8 ohm resistive loads connected to the speaker terminals for the pair A, but they're not connected because I haven't yet pressed in this button here. If I turn up the volume control, we can see the amplifier still seems to be working as expected. But now I'll switch on the loudspeakers. So now the amplifier is driving both of its outputs into the 8 ohm loads. I'll turn the volume control up until the outputs just start to clip. That waveform has an amplitude of about 70 volts peak to peak. The vertical scale allowing for the adjustment for the times 10 probes I'm using is 50 volts per division. So a quick calculation from that suggests the amplifier was producing output power of 77 watts into each channel. I disconnect the loudspeakers again and turn the volume control up so we can see the output signal again. Let's test some of the other controls. So for example, this is the balance control. Turns all the way to the right and all the way to the left. That seems to be working as expected. I'll switch the test signal to a 1 kHz square wave. Okay, so this control here on the left is labelled tone defeat. And the idea is that when it's out as it is now, the tone controls are not effective. If I enable the tone controls, I'll try adjusting the treble control. This is with full treble boost and full treble cut. Put it back to somewhere in the middle. And now the bass control, full bass boost and full bass cut. So the tone controls appear to work as they should. There's one other feature that's controlled by this button here, that's labelled the subsonic filter. I would expect that to attenuate very low frequencies. So I'll switch the test signal back to a sine wave and to a frequency of 20 Hz. Which means I need to adjust the oscilloscope. So according to the label on the front panel, the subsonic filter is active when its button is out. So it should be active now. So if I press it in, we should see an increase in amplitude of the test signal. That seems to be the case. Reduce the volume control slightly. So the subsonic filter is enabled and now disabled. So yes, it is attenuating low frequencies. And it looks as if that filter control is active regardless of the setting of the tone defeat button. Among the few technical notes I have for this amplifier is a description of 3 procedures that should be used to test the ASO, Area of Safe Operation Detection Circuit. That's the circuit based around IC901 down here, and it controls the relay that connects or disconnects the loudspeakers. For the first test, it says that a 1 kHz test signal should be connected to the tuner input. I'm sure the aux input would work just as well, but I've connected it to the tuner input as requested. Then the input level and the volume control should be adjusted to produce a signal of 5 volts RMS at one of the loudspeaker terminals. To help me do this, I've connected the oscilloscope probe to one of the outputs here. The test signal is already turned on, so I will switch the amplifier on. The relay has just connected the speaker outputs. So now I'll adjust the volume control. So 5 volts RMS is about 14 volts peak to peak. So that's about right. Then it says one should briefly short circuit the loudspeaker output that's being monitored, and that should cause the relay to disconnect the output signal and it should remain in that state until the amplifier is powered off. So this lead is connected to the chassis, and if I touch it briefly on this terminal here, that'll have the effect of shorting out that output. I heard the relay click, and as indeed you can see, the output has been disconnected. I'll switch the power off. Now I'll switch the amplifier on again. Hopefully the relay will activate and reconnect the output. As indeed it has. So that test has passed. Another one of the tests describes how to check a temperature detection circuit. So I assume this is a circuit that disconnects the outputs should something inside the amplifier get too hot. And it describes a test using a 10 kilo ohm resistor to connect the gate of component HA-901 down to ground, and that will simulate it detecting excessive temperature. HA-901 is down here right next to the relay, and of course I could do that, but I thought, why not just heat it up and see whether it switches the relay off. The air coming out of this should be at about 160 degrees centigrade, and I'll carefully use it to heat up HA-901. Hopefully it will disconnect fairly quickly because I don't want to overheat the surrounding components. There we go, the relay has disconnected the output, so it looks as if the temperature sensor is working properly too. There's one more procedure described in the ASO detection circuit test notes. However, I'm not going to do that. It involves connecting a voltage between pins 2 and 3 of IC901, and I think it could be rather difficult to attach test probes there without shorting something else out. I can see from the circuit diagram that these inputs are labelled neutral point detect, and also from the diagram that they must be used to monitor the outputs for unacceptable DC offset. From the behaviour of this amplifier the first time I turned it on, when the op-amp power supply voltages were missing, I'm confident this part of the ASO detection circuit is also working properly.
As you can see, I fully reassembled it and attached a pair of loudspeakers. After testing all of its inputs and all of the front panel controls, I've been listening to music playing through it for about 2 hours without any sign of any problems. I've connected an external microphone preamplifier to one of its inputs, and it's via that path you're listening to me now. So I'm pleased to conclude this amplifier is now fully working. There remains a slight mystery of the two failed 220 ohm fusible resistors. I wasn't able to find any reason for their failure, so I think I'll have to conclude they simply gave up due to old age.